Today we will be talking about integration using substitution. Let's say you have the integral of the square root of 3x plus 1. The first step is to make the integral easier to integrate, as this integral isn't easy to integrate at first look. To make it easier, we will make the inside of the square root a more simple expression. We will let u equal to 3x plus 1. So du is equal to 3dx, and we isolate dx by dividing both sides by 3. So du over 3 is equal to dx. This will make the integral equal to the square root of u times du over 3. We factor out 1 over 3 from the integral, and we change the square root of u to the power of half to make it easier to integrate. Now to integrate this, we add 1 to the exponent and multiply u by the reciprocal of the new exponent. So half plus 1 is 3 over 2, or 1/2. The reciprocal of 3 over 2 is 2 over 3, so the antiderivative is 2 over 3 times u to the power of 3 over 2 plus the constant c. We simplify, and we get 2 over 9 times u to the power of 3 over 2 plus the constant c. The last step is sub back in 3x plus 1 for u. And our final answer is 2 over 9 times 3x plus 1 to the power of 3 over 2 plus c. Let's look at another example. Let's say we have the integral of ln x squared over x. We know we use the technique substitution because we see ln x and its derivative 1 over x in the same integral. So we let u equal to ln x, and du will equal to 1 over x times dx. We isolate for dx, and we get x times du is equal to dx. Our integral now becomes u squared over x times x du. We can see that the x cancels, and we are left with the integral of u squared, which is now pretty easy to integrate. So the antiderivative will be u cubed over 3 plus the constant c, and the last step is to sub ln x back in for u. And we get that our final answer is ln x cubed over 3 plus c. Let's look at one more example. Let's say we have the integral of sine of the square root of x over the square root of x. To make this integral easier to integrate, we will make u equal to the square root of x, and du will be equal to half times x to the power of negative half times dx. We isolate for dx, and we get that 2 times the square root of x du is equal to dx. Now our integral becomes sine u over the square root of x times 2 square root of x du. We see that the square root of x cancels, and we can factor out the 2 from the integral, which leaves us with 2 times the integral of sine u. Now this is pretty easy to integrate. We get that the antiderivative is negative cos u plus the constant c. We sub the square root of x back in for u, and we simplify, and we get that our final answer is negative 2 times cos of the square root of x plus c.